force tennis problem. I think we got the data into our calculator. I know it was rushed at the end, but we got our t-value. Then that's pretty far out there. We got our tiny p-value, so we rejected. And we did decide that advanced was greater than intermediate. Is that right? We got all that. And we did not do the confidence interval, right? Okay. So again, at this point, the hypothesis test does tell us, yes, advanced uses higher force. But I still want to know, well, how much is the force? And you don't get that from the hypothesis test. So we're going to do a 98% confidence interval on the difference in force for advanced and intermediate players. And it's okay if you don't still have to put it in your calculator. We have enough stuff here. I'm still, the entire problem I was doing advanced minus intermediate, so I'm going to keep up with that. So I've got to pull the advanced mean minus intermediate mean, plus or minus, we'll come back to the t. And I like mu problems because I get to steal my standard deviation term. Now remember the t critical value. This is coming off of our confidence interval chart. And we say to take the smaller n, which is 6, minus 1, which will be 5. So degrees of freedom is 5. If you go to your confidence, so again, don't pull this t from the hypothesis test. We're getting it off our confidence interval chart. And if you go to 98% at degrees of freedom of 5, you will see 3.37. If you have your data in, you can run 2samp t int, and if not, you can just trust me. So it's been 2samp. We used to go to 2samp t test. Now we're going to go to 2samp t int for interval, and you'll get this out: 3.4 to 34.4. Now we've got to interpret that, particularly if we had not just done the hypothesis test. Sometimes I might have you do a confidence interval to answer a question or something. The interpretation of 2 sample problems is dramatically different than the interpretation of 1 sample that we did on test 3. And it's always best if we learn sort of the short, sweet, correct way of saying it. So, but also, see, now that we're in the middle of a formal, problem, it's easy to get confused, and that's why I still bring it back to whoever I was comparing to Joseph's height probably the other day. These numbers here have nothing to do with the force of advanced and nothing to do with the force of intermediate. They're the difference between the two. So like when we had figured out that Joseph was probably 13 inches taller than the girl I pointed out, we knew that she wasn't 13 inches tall and Joseph wasn't 13 inches tall. He was 13 inches taller. So make sure you know that these are not their original forces. This is the difference in the forces. It is such a wide confidence interval. So that comes back to those little pick the best choice questions I put on test 3. We have pretty high confidence. Made my interval wider. We had very low sample sizes. Made my interval even wider. This is an extremely wide confidence interval when it comes to forces. But anyway, how do we interpret that? Okay, it's kind of like 3 little phrases. Since I did, what did I do? Advanced minus intermediate, and got all positive numbers. So you look at your confidence interval, they're all positive. And got all positive numbers. So if I've gotten positive, that means my first number has to be bigger. The advanced has to be bigger. Advanced is bigger, larger, whatever word you prefer. Kind of already knew that though. I was still trying to figure out how much larger. Well, remember, that's what the confidence interval is. Anywhere between 3.4 to 34.4. I don't know, somewhere in there, and I know it's pretty wide. That confidence interval is actually measuring how much more. But you got to tell me what you did, because if you had done the opposite, this would be completely backwards. We got kind of lucky here in that just the way we randomly decided to set it up, I had positive numbers, and positive numbers are always nicer. Let me just run through the what if scenario. What if we had done intermediate minus advanced? If we had done intermediate minus advanced, I can tell you your confidence interval would have been this. Again, just like when we did short girl minus Joseph, we got negative 12 inches or whatever. So that negative is just coming from how we chose to subtract. It doesn't mean anybody has a negative force or anything like that. So since I did intermediate minus advanced and got all negative numbers, well, let's see, if I got negative, that means my second number is bigger. X is larger by 3.4 to 34.4. So of course, the exact same conclusion. And don't get tricked, make sure you don't tell me they're negative forces. Again, you can pretty much ignore the negative and then just talk how we always do, 3.4 to 34.4. So same conclusion, of course. But that's what it would look like. In just a minute, we're going to start our last new hypothesis test and confidence interval. So questions on this. So that interpretation, you have to talk about what order, you know, all positives or negatives, and which one that means was bigger. So our next one is still going to be two sample stuff. It's the paired matched problems. But this kind of idea of how to talk when we're interpreting it, since it's still focused around 0, will be the same. It's just sort of the setup of the problems is quite a bit different. Take a picture. I don't mind, and then it saves. I never mind if y'all take pictures of those. Because I'm also, since we're videotaping, I'm trying to fit into a little square here. You good?
Thank you.
All right, so our next topic, and again, this is our last new one, so that's why tonight, well, today we're finishing up all new material. So tonight we should be able to do everything and anything. And so the next few days, I call it review, but it's really, let's just pick a problem and see if we can figure out how to solve it now that you've thrown out 4 different things to me. But right now, we need to get through 9.3. Matched paired samples, still doing difference in means. Handout 16, and if you just visually look at number 4, you're going to see 2 columns of data. For matched pair samples, we are going to actually have to literally take the subtractions of each pair of data points. It's like they're partnered up. So we're going to have to subtract each one. So really, in essence, we've taken a 2 sample, it was 2 columns of data, but if we then subtract them, we boiled it down, compressed it down to 1 sample. And that 1 sample is the differences, the subtractions. So matched pair kind of is emerging between 2 sample and 1 sample. It uses techniques of both. And then, so you can imagine, we'll have this 1 sample of the actual subtractions, and we could get the mean and standard deviation off of those just to show you some standard notation. A lot of times they'll put a sub D on those, and that sub D means difference, referring back to the matched pair. That is the differences on them that I actually took the subtractions. This will be the longest. Sometimes they already do some of the work for us, but this is if they have given us the original data. I'm going to kind of have to do this. Again, on your cheat sheet, some of you noticed this a week or 2 ago. When we were doing the 1 mean, actually that box is called 1 mean or matched pair. So see, because the matched pair boils down to 1 mean, so we are back to using what looks like our 1 sample test, where HO, now I'll put a D on it just to remind us it was those differences. And it is centering around 0, while the 1 samples we used to do was whatever number they were asking about, 8,000 for that uptake of nitrates or whatever some of those other ones we were doing were. X bar D minus hypothesized value, but I don't have to show minus 0. And then we are, basically running the t-test. It's just, you got to remember we're doing it on the differences. So while it looks maybe short and sweet, there is some, we have to remember it's a little more complicated. Let's do number 4. So it's handout 16, the very first paired problem, which is called number 4. And both, we're going to do 4 and 5, but all these problems are completely footnoted with real research. Obviously, it's a bit dated, but that's, gosh, I got one from 1983 in here, but that's okay. I don't know that these topics change very much, at least these 2. So this was that one, yeah. Does the lactic acid in your body, the blood lactate level, does it go up after exercise? So it makes sense to get a group of people, I measure you now. I send you, run to ISAC, come back, then I measure you again, right? I wouldn't want to compare your before exercise levels to you guys after, because you guys might have a different starting level. You might be more physically fit or less physically fit, and that might affect how quickly that lactate level changes in you. So the same group of people are in each one, and that's that before and after we talked about last time. So it's definitely a paired problem. Why don't we all put the befores into L1 and the afters into L2? Why did I choose to do that? I just looked and it just seemed to make sense because one was on the left and one was on the right. It really does not matter. Go ahead and get that stuff in first. So, I'm going to poke at L3 in a second. And this morning I was asked, can I figure out how to put it on L3? So, yeah. You know how to do it? Oh, no. Boy, it's super, I mean, I don't know how either.
I've been trying to mess around.
You don't have to. It's probably different. You literally can say, hey, you have to do in your head. But even if it doesn't, it's only going to take you 1 minute to literally subtract those, right? Those 8 numbers down or whatever. And then we'll put those 8 numbers into okay? So just to let you know, it's, I mean, it's, I don't really know it's going to take you any longer than the technique I'm going to show them.
Okay.
She's my only Casio, right? Calculator, okay. All right, so some of you may have heard a little bit of what I told her, but these numbers are pretty easy to subtract. You can probably do them in your head. There's only 8 of them. But again, in real life, what about if there were ugly decimals? What about if there was a whole lot more than 8 of them? You may not want to have to subtract them yourself. you can always let the calculator subtract them. So take your arrows and go get L3 highlighted. You got to be above the horizontal line. You can't be in that first entry. And then your calculator's sitting down here saying, what do you want it to be? I want it to be L1 minus L2. Second of 1 minus second of 2. And when you hit enter, it should fill all of this in. The first one should be -5, so you'll know if you did it right. So basically now, L3 is the column of our differences. In a few minutes, we're going to be running, not now, but in a few minutes, we're going to be running a t-test on L3. You just got to remember that if you did let the calculator do that for you, your differences are in L3 now. Did everybody get the -5? Yeah.
Why couldn't we do like L2 minus L1?
No, you can. Remember, there's always 2 ways to do all this. I just had to choose one way. And literally, why did I do it? I went left and one was right. That's the only reason. Your way would probably make the problem a little bit easier.
How do you put in the L1 minus L2?
Okay, so you got to be up at this, up. Yes, good. Now, second of 1. No, you left it. Okay, second of 1 minus second of 2. Yeah. Huh? Something's messed up in here, so let me see if I can get things back. Now you'll be able to do it. Something had gotten named differently, so I needed to reset what your L3 was named. Okay, so let's see. Just because it naturally seemed to happen to me, I've decided that I'm doing before minus after. That's the way I just programmed it. So that's how I'm going to do my hypothesis test this whole way through. You could have done it the other way. But basically, you have to take what subtraction order you're doing plus the question that's asked. It takes those 2 pieces to figure out if we're doing a greater than 0 or less than 0. So that's what I'm doing. And where's the question? It's underlined. Do lactate levels go up after exercise? So if I'm doing little number minus big number, do I get positive or negative? I get negative. So my entire hypothesis test is going to be less than 0. If you did after minus before, you'd be doing greater. So let's kind of make it all formal now. And here's probably step 1 and 2 are kind of the confusing parts. I'll point out where sometimes people mess up on the test. I have this one column of differences now. So really, I'm doing mu less than 0. Or if you want to put the sub D to remind yourself they were the differences. There's no mu1, mu2 thing. It's just mu versus mu equal to 0. Now in step 2, that's our kind of definition spot. You do have to tell me that mu sub D is defined as mu sub before minus mu sub after. Because that's the only spot that you're going to make reference that you've done your entire thing as before minus after. And then you have to go on to say, what do you mean by mu sub F? Mu sub BEF is true, mean, lactate before exercise. Mu sub F is true, mean, lactate after exercise. And in a roundabout way, they stated normality. That whole, oh, the box plot looks fine, is the authors of that book kind of trying to use a real-life technique to show you that sometimes we look at box plots in real life to see if we think it's normal. It all looked fine. Let me show you where some people do it wrong on test 4. Because the problem sometimes is, see, like if you know you're a confused student, you will go to the cheat sheet. But if you think you're not confused, then you may not go to it when you really should. So always kind of double check things. Meaning, this is not like algebra. I don't know if y'all remember the substitution method. You can't say, oh, well, I just said mu sub d is this, so let me put that there. No, because that's the way we set up two sample independence. So what I mean on the cheat sheet, it reminds you, if you're doing a two mean which is independent, you are going to have mu1, mu2 in the HO and HA. But if you're doing a matched pair, it shows you're only allowed to have one mu in that HO, HA. You can't have mu sub def minus mu sub aft up here, because that's indicating an independent, and then those formulas are completely different. We have to match up this data. So it has to look like this, and then you just define it in sort of the definition step. All right. Now, whenever we have real data, I can't really even do my step 3 until we do the calculator work. So now, you are going to run your t-test on L3. You can't forget to change it to L3, because I think the calculator probably still have L1 sitting there as a default. Lots of people have been forgetting this today. They're leaving out probably whatever was in there from 2 days ago. Your mu sub naught is always, just look at H sub naught. Your mu sub naught is 0. You got to pick less than. People messing that up. And you got to run it on L3, so you're going to be picking data, right? Since we have data in there. Do all that, you should come up with this.
So essentially, if you did it the other way, after minus 4, you would just do that the 2L's would be this, and then you would do greater than.
Yes, absolutely. And right now, I'm about to get a negative test statistic, and you would get a positive. I'm going to have a negative mean, and you have a positive. So once you run that, you'll see the x bar, the s, the n, so you can show the formula. You'll see what the t is. We'll pause here to see if there's calculator issues. Yeah. You never program L3. You missed that step earlier. So get up above, yeah, now go second of 1 minus second of 2.
Okay.
Because, yeah, you had a blank column. Well, that's what, so remember that sub-0 is really matching this sub-0. What number do you have in HO and HA? 0.
So that's all it's.
Yeah, on this one, that's the same for no matter what hypothesis test we're doing. You always look at the HO and HA. Whatever number's there is the thing that's going in that.
Oh, I was looking at the wrong numbers. I thought. Okay, awesome.
Yes, t-test, yes. Yeah. Okay. So now I can at least talk about my problem because, well, even backing up, I know nothing about lactate level and like what's big and what's small. But I am seeing that, at least for my sample, there was a difference of 13.6. I don't know. Is that a big difference when it comes to that blood level? Or is that just random variability? That's what we're trying to test here. Now that I see this, well, check here. I did less than, I got my negative, so I'm good there. If this were the Z chart, I would know I had fallen off, but it's not. So I'm always a little nervous when it's the T. And to be honest, what makes me even more nervous is that I have a tiny sample size. I mean, I definitely know I'm out in this tail. I just don't know exactly, was I a hair from falling off the cliff or a foot, basically. So I'm somewhere out here. My p-value is the probability that t is less than this negative 4.65 I got. Look at your calculator for the p-value. Tiny. I mean, not 0, but tiny. 0.0011. I'm comparing that to alpha. 0.01. Is 0.0011 less than or equal to 0.01? Yes. We're going to reject HO. There is evidence of what was asked. There is evidence the blood lactate level goes up after exercise. is evidence of that.
Were everything on my calculator the same except for the value?
You picked the wrong symbol. No, you didn't put in 0, you put in 8. You see, I always walk around like, you less than 8. Now we're supposed to be doing you less than 0. But again, okay, fine, it goes up, but how much up? I'm not going to get that here. So let's run and this, I may not have even asked you on your sheet, I can't remember. Run a 98% confidence interval on the difference in lactate level for advanced. Nope, I'm going back for before and after. These are so similar for before and after. Now I am reminding myself that my entire thing was before minus after. No reason to switch that now. We'll skip the setup, but all you have to do is go to t-interval. At this point, everything should be there. It should have your L3 from where you changed it a second ago. All you have to do is put in 98%. And you should get negative 22.4 to negative 4.9, something like that. They're very okay with that before we interpret it. Okay. Since I did before minus after and got all negative, that means my second number has to be bigger. After has to be bigger. After is bigger, larger, whatever. Again, we already knew that. How much bigger? Between 4.9 and 22.4. They didn't give up. I think this is a level. I'm not sure that there's a unit. They didn't give me the unit, and I don't know what it is. So between 4.9 and 22.4, bigger. Again, to me, this seems like a really large, wide confidence interval. Same reasons. 98% is pretty high. I still had a tiny sample size of 8. The next problem we do will seem a little more reasonable. The reason why I pick things with small sample sizes is so you don't have to type in data all day.
What's the word after bigger?
Larger, whatever word you want to use.
So bigger / larger.
Yes, what he said.
I'm just confused where you got this. Did you put that in,
Did you go here?
yeah, is that the one prop C in? Or
No, it says
it's-
t-interval.
oh,
Yeah, that's, I mean, it's the exact. Yeah, you gotta keep going to, yeah, there you go. So that's it for that problem. We're gonna do number 5 now, but questions on this one? I mean, if you kind of just look at number 5, it's like, oh yay, I don't have a bunch of data to type in. So they've already done some of the work for us. So again, number 4, the one we just did, is the longest. We had to do everything sort of from scratch. They're not all that long. So let's do number 5. You can read it while I erase. Very real topic again. Even though this is 1983, I don't see why this topic would change at all in the last way too many years. See, 80 don't seem like that long ago to me, but. Bottom line to this problem is, do people get nervous at the dentist? And at least these couple of problems here, I probably have a little more knowledge than some of the ones we do in here. But this is a very true thing, or at least for some people. When I had first moved to the area after college, I was, you get your own dentist, you're not on parents anymore. So you call up to make a new patient appointment, and the first question they asked me was, do you need to be sedated? And I kind of hesitated. I said, I only want a cleaning. I'm not getting cavities. I was a little taken back. And now I know, we know, some people need sedation just for a regular cleaning. I was like, wow. I said, no, I don't need to be sedated. And that was one of their general questions they asked new patients on the phone. So ties right in with this. Now, why would a dentist care if you get nervous? And why do we even care if someone's getting nervous at the dentist? So this is brainstorm time. Why do dentists care?
Could affect their dexterity if you're moving around and whatnot.
Good, so they can't work in there as well. More, you're right. What else? That's just kind of an inconvenience. What else could happen?
Well, my dad's a dentist, so he sees a lot of this stuff. But it could also affect, what people say about them, perhaps. Their opinions. Kids,
Absolutely.
Especially. There's a lot of kids.
So of course, since I had the dentist kid, you were keeping very real life, and I appreciate it because you were right. Go a little to the extreme. And I don't know, actually, do you have any interesting stories that maybe your dad has told you? Have there been any crazy?
In terms of people being too nervous.
And freaky in the chair.
Yeah, usually it's kids, and he has a board that he'll tie them to if they're like really getting out of hand. But lots of time if people are too nervous, he'll either refer the kid to a pediatric dentist. Or just give them nitrous oxide.
Laughing gas. It's a wonderful thing.
Yeah.
Wonderful thing.
My cousin's a dentist. She said she gets bit a lot.
See, that's where I was going. I wasn't sure. Has your dad ever gotten bit?
That's a good question.
Oh, you have to ask
he's
him.
never really alluded to that, but it's certainly possible. Maybe it's because hygienists do a lot of the cleanings and stuff like
Very
that, rather
true.
than my dad who does surgery.
You're right. At that point, because they usually come first at that point,
Yeah,
maybe
yeah.
they've calmed him down for your dad.
I'm sure someone's gotten bit.
Yeah.
Yeah, my cousin's right at dental school, so she just had to do all the dirty work too. So
Right.
Yep.
See, it's so interesting. No one has known anything as we brainstorm. You two actually know something, but the rest of us just brainstorm, oh, maybe they'll get bit. And, it sounds kind of funny, but I'm like, yeah, if I'm going to freak out and chomp my mouth down and your fingers are in there. So maybe the dentist doesn't want to get bit or just not having a good experience, which does affect reputation and getting new patients. So dentist being bit, but also what could happen to the patient in there? So forget you two who actually know what's going on. The rest of y'all have had cleanings. What's in your mouth when they're cleaning? Sharp tools, right? And if you decide to jump up and they have that little pokey thing in there, then it might cut you, and they don't want to do that, just for lots of reasons they don't want to cut you. So that idea of if you get nervous is important. Now, the only issue, and there's no way around it, I'm just saying it out loud. Ideally, they would have measured your blood pressure on the sofa at home watching TV where you're the most relaxed, right? Well, of course they can't do that. That's not, completely structured and regulated. So they are comparing it to what they call the medical setting. But I'm just brainstorming now. If you're a real jumpy person, very nervous person, you might just get a little bit nervous just going even to the doctor. So where I'm going with this is, if we see a difference here, it's probably even a little bit more in real life, knowing that they measured you at the doctor, which probably made those nervous people a little nervous anyway, as opposed to what your resting rate, very relaxed at home is. So, all right, it's all footnote, da-da-da-da-da. Now, again, I can tell they didn't give me any data, so what happened? We're only going to do blood pressure, not the pulse. What have they given me? It says for each subject, the difference, they're doing the subtraction, they already did it for us, was calculated. So they already calculated the subtractions. They already kind of did our L3. But then they actually went ahead and calculated the X bar and the S of our L3, so they didn't even give us the entire L3 to look at. They've done all the dirty work for us. So when they have already done the work for you, you have to use the order of subtraction they have done. And they tell you in parentheses. They did dentist minus the medical setting. And of course, dentists are doctors, but I'm just using that as the medical setting. So that's what they did, and then they told us X bar for, again, I'm focusing on blood pressure, and S is 8.77. And then there's the question. So I know that's the order of subtraction, then I have to take the question. Basically, does blood pressure go up at the dentist? So if blood pressure goes up, big number minus small number gives me what type of number?
Positive.
Positive. So that's sort of my background. Now I'm going to pull this together. So my HA is going to be mu greater than 0 versus mu equal to 0. And what I mean by mu is mu sub dental minus mu sub medical setting. And then mu sub dent is true mean blood pressure at the dentist. Mu sub medical is true mean blood pressure at the medical setting. How do I have normality here? And the first time I read this, I had to read it 3 times because I just visually missed it. How do we know we have normality? So look through the problems. I actually made a visual mistake. I could not visually see it. What am I talking about?
The number of subjects?
Yes, which is 60. I don't know because it was hanging out at the end of that sentence. I never even saw it. 60 greater than or equal to 30. I'm good to go there. So they did tell you an N. Hey, since I have the summary statistics, I can actually talk about this and set it up. X bar over S over square root of N. So again, what we're trying to figure out, I know on average for these 60 patients, they're systolic. So systolic is top or bottom of your blood pressure? Top. So kind of what's supposed to be average, 120, 110, whatever. So that's the number we're talking about on average changing about 4.5 points. And we're trying to figure out if that's a lot or just random variability. I don't know where to draw 4.47. I mean, it's going to be up here somewhere until I actually get that t-value. So you're running a t-test. You're going to pick stats this time, right? Because they gave you X bar and S. So we got to save quite a bit of work. You probably already have that 0 in for mu sub 0, but always check that. Change the sign. This one has a greater than. You should get a T of 3.95. They may need calculator help. So, okay, if this were the Z chart, yeah, I would have fallen off up there. It is the T, so I'm not sure if I've fallen off, but I am feeling pretty good because I have a sample size of 60, so that makes me feel, I'm actually thinking I'm probably right at the edge. P-value is the probability that T is greater than 3.95. Now, if you give to me what your calculator says, I'm not going to accept it because your calculator just gave you the p-value in scientific notation. So you have to make sure you translate the scientific notation, 0.0001. If you were looking at a p-value of 0.9999, you forgot to pick the greater than symbol. So just make sure you translate that to 0.0001. And I think I gave you pretty small alpha again. Yes, of course that's less than or equal to 2.01. Reject HO. There is evidence blood pressure goes up at the dentist. Well, it is, but it's not called one sample, it's just called t-test. On you, it's probably called one sample.
Okay.
Yeah, sorry.
Can you walk in, sorry?
Yeah.
What is mu sub?
Oh, mu sub naught. So remember that sub naught matches my H sub naught, that's 0.
Oh, okay.
Yeah. Yeah, whenever it asks for mu sub 0 or p sub 0, it's basically saying what number do you have in HOHA.
Okay.
So a couple of things that question that has come up today, particularly probably after this one. Remember that p-value less than or equal to alpha, you reject HO, and I put a box around it, and I said that was never in your entire life going to change. I meant it. That rule has nothing to do with what sign you're using in HA. Nothing to do with it. The rule is for no matter what hypothesis test you're doing, if the p-value is less than or equal to alpha, we reject HO. That's not going to change depending on how you're setting something up. Some people have been getting confused on that. But again, you're telling me it goes up, and here's kind of real life. Sometimes we'll read summaries of research, depending on who summarized it, and they'll be telling me it was statistically significant that it went up or whatever. Usually not enough information. I really want a confidence interval. I want to know how much. How worried do I need to be, basically? I mean, are people going to start having heart attacks in my chair, right? I need to know how much this is going up. Should I be overly worried? So let's run a 98% confidence interval. Just go to T interval. At this point, probably everything should already be in there. .8, 7.2, something like that. Well, I'll go through it one more time. Since I did dental minus medical and got all positive, blood pressure goes up at the dentist by how much? By 1.8 to 7.2, whatever that's measured in. I don't know. So, because remember what we don't know. We don't know what you're starting at. I don't even know what high blood pressure is. But if you have high blood pressure, maybe going up 7 points could put you in a very dangerous position. If you're sitting at 110, 115 to begin with, I don't know that it's going to be an issue that you get up to like 122. So it's probably going to, of course, depend on the person. But what I really want to make sure you understand, because, again, doctors or someone can talk about whether this is a lot or not. I feel like it's not, but don't trust me on that. But I want to point out, maybe just a by the way. Even if the difference had been 0.1 to 0.2, it would have still been statistically significant. We would have still made the statement, yes, blood pressure goes up at the dentist. But that's why it's so important to always say, but how much? So then either you can, that's that practical significance we talk about, how it relates to you, or even real life. I mean, this isn't just relating to you. I'm not even sure you can measure blood pressure that closely. At least you're not going to get it with a human and a stethoscope, and I'm not sure if there's a machine that will measure it that precisely. But that top number, I do know that a difference of 0.1 or 0.2 does not matter. But it would show up to say, yes, blood pressure goes up at the dentist. So that's why you really need the confidence intervals to accompany it. So I'm still not convinced that's a lot, but that's not up for me to say. I definitely know that's not a lot. So in real life, totally making up numbers here because it's never been a topic I care to spend my time looking into, but Kaplan SAT prep stuff. I do know, I think they kind of guarantee that it will go up, or I don't know if they give you all your money back, I'm not sure. But let's say Kaplan says, listen, it's been statistically shown your SAT score after you pay us $1,000 and we make you practice, will go up 10 to 20 points. It's statistically significant. Now in that case, it's going to be up to every individual to decide, is that worth $1,000 to you? Some people might say, I'll take anything I can get. Other people might be like, no, it's not worth it. Now if Kaplan says, hey, we'll raise it 100 to 150 points for $1,000, you might be like, oh, okay, that is significant to me. So some of these things, whether it's practically significant to you, just depends on your opinion. Some of it is more from a medical standpoint. Do we really care about that? Definitely not that. So confidence intervals give the whole story. The last couple of minutes, I just want to look at a couple of problems on handout 17, maybe just give a few helpful hints, but not critical. Are there questions here before we do that? Grab handout 17 out, because a lot of these paired problems are all worded just slightly different. I wanted to point that out. So we've had the longest problem that we started with, and then a pretty short problem. There is an in-between. Number 12. Number 12 was the picking up dried beans with my dominant and my non-dominant. Same people in each group. So it's definitely a paired. I only see one column or row, whatever, of data. So that tells me they've already done the subtractions. And they tell you, we've already done them. And we did dominant minus non-dominant. And here are the subtractions. So it's kind of like they gave you L3. I mean, of course, you can put it into your L1. But they didn't give you the X bar and S. So you'd have to type that in. But those are the differences. Those are not how many beans someone's picking up in their hands. You can pick up more than 5 beans. Those are the differences. Look right above it at number 11. Want to make sure you catch that this is a paired problem. Basically, it's 2 types of lecture methods. Here at JMU, you could call it the lecture classroom or the flipped classroom. So if people are attending, they're different people. You're either going to the lecture or you're going to this, what they call PSI or something. Different people. But there is an extra sentence. Students are paired by matching those with similar math background and performance. So that's what I meant the other day when I said there would be an extra sentence saying we paired them by some other variable. So number 11 is a matched pair, very similar to the first problem we did today where you're going to have to get the subtractions start to finish. Where's my women? Number 9, one I was referring to. How tall are you? How tall do you want to be? We asked the same women, so that is a paired problem. This is probably the weirdest one on here. You're looking at it, I don't have real data, they didn't give me anything, so they must about to give me my X and my S, right? And I see the S sub D, they say it's 2.1. I'm like, okay, they gave me the difference, standard deviation. But it's like, why did they give me the separate means? Because they were trying to be difficult. So it is mathematically correct and appropriate to actually subtract the 2 means from each other to get the mean of the difference. You can do that. You cannot do that with the standard deviation. That's why they had to give it to you. But they know that you literally can just subtract those 2 means to get X bar D. So you actually have your choice on this one. If you want to do desired minus actual, or if you want to do actual minus desired. It will depend on how you subtract those 2 numbers. But that is a paired problem, even though it almost makes it look not paired because they gave you 2 X bars. Because then you'd be like, well, where's the other S? And you only have 1 S. So number 9 is paired. I think that was, yeah, that was all the comments, some of the paired ones I wanted to just give you a few hints on. So, all right, we are done with new material. So Friday, Monday, Wednesday, we're just going to work problems, particularly like handout 19. They're just random problems on a sheet of paper. We have no idea what topic they are. We have now 4 hypothesis tests and 4 confidence intervals. And you have to figure out which ones